Alrighty, today we're going to be looking at section 6.3, which is definite integrals. And antiderivatives. First thing that I need you to do is and you'll probably want to pause the video to do this in a moment, but you want to go to page 289 in your textbook. There's some rules for definite integrals here. There's 7 of them. I want you to copy those into your notes. So instead of me having to actually write those up here on the board, I want you to do that at this time is to copy those rules down. So go ahead and pause the video if you want to and copy those rules down, please. All right, we're going to move on now with an example from those rules that you should have paused the video and copied down. And we're going to be looking at an example of using those rules and those properties of definite integrals. So let's say, for example, I'm given the integral from -1 to +1, f of x dx, and that's equal to 5. And the integral from +1 to 4 of f of x dx is equal to a -2. And the integral from -1 to +1 of h of x dx is equal to 7. Okay, and we want to find first part, we want to find the integral from 4 to 1 of f of x dx. Well, that's just these bounds flipped. Here was 1 to 4, here's 4 to 1. If I flip the bounds, I'm changing the sign of the area, basically. If I go in the opposite direction, my area changes sign. So instead of being a -2, this will be a +2. That's using the rule on the previous that you copied down, your order of integration. That's rule number 1. All right, part B, let's say we want the integral from -1 to +4 f of x dx. Well, we already know that from -1 to +1 is 5, and from +1 to 4 is -2. So if I add those together, 5 plus a -2, I get my answer of 3. And that's using additivity, rule number 5. All right, let's say instead we want the integral from -1 to +1 of the quantity 2f of x plus 3h of x dx. I can break this down into separate integrals. That's going to be the integral from -1 to +1 of 2f of x dx plus the integral from -1 to +1 of 3h of x dx. It's using a sum and difference, plus these are constant multiples so they can come out in front. So that's 2 times the integral from -1 to +1 of f of x dx plus 3 times the integral from -1 to +1 of h of x dx, constant multiple rule. And then I already know that this one is 5, and I know this one is 7, so that's 2 times 5 plus 3 times 7. So that's 10 plus 21, that's 31. That's my answer. Okay? So you can apply the rules based on your given information. And I can ask questions where you don't have enough information. Like if I ask for the integral from -2 to +2 of h of x dx. That, I don't know anything about -2 to +2 for any one of these. Definitely not for h, so I don't have enough information. So it is possible to not have enough information to answer a question. Okay. All right, we also have another definition to look at here. We're going to be looking at the average value of a function, or mean value. This is moving towards the mean value theorem for definite integrals. We had a mean value theorem for derivatives, if you recall. There's a mean value theorem for definite integrals as well. There was a mean value theorem for derivatives in the last chapter. So this is for the definition of an average or mean value of a function. If f is integrable on AB, its average, again, parentheses, mean value on AB is 1 divided by the quantity b minus a times the integral from a to b of f of x dx. So we can use this to find an average value. Find the average value of f of x equals 4 minus x squared on 0 to 3. Here's my a and my b. So I'm going to have 1 divided by 3 minus 0 times the integral from 0 to 3 of 4 minus x squared dx. And for now, since we don't know how to do this out analytically, we'll use the calculator to do the numerical integral for that function right there. Okay. So that's 1/3 times this. That'll give me use alpha window number 4, 0 to 3 of 4 minus x squared dx. You get 3. So 1/3 times 3 is 1. So the average value of that function on 0 to 3, the average value of 4 minus x squared on 0 to 3 is 1. This leads us to the mean value theorem. The mean value theorem for definite integrals. Sorry. Which states if f is continuous, if f is continuous on AB, then at some point C on AB, at some point C on AB, f of C is equal to 1 divided by B minus A, all times the integral from A to B of f of x dx. Notice that's the definition of the average value, which we had over here. So let's say we wanted to find the C that satisfies the mean value theorem for f of x equals 4 minus x squared on 0 to 3. Let's say we want to take that example we just did. Now we want to find the C that satisfies that. That means f of C has to equal 1 divided by B minus A times the integral from A to B f of x dx. We already found this to be 1. All that was equal to 1. So 4 minus x squared, plug C in, you get 4 minus c squared has to equal 1. Where does that occur at? We solved this. That means that if I subtract 4, I get negative c squared is equal to a negative 3. So c squared is equal to a positive 3. So c is going to be positive or negative the square root of 3. The only one of those values that's on this interval from 0 to 3 is the positive square root of 3. So that occurs, the value that satisfies, we would say that therefore, the value that satisfies the mean value theorem is C is equal to a positive square root of 3. All right, so please take notes from hopefully you've taken notes from this, and I'll assign some problems for you to look at today.